Hello and welcome to Education at SSBJ online video tutorial. We are in revision mode and we had taken chapter chemical effects of electric current of class 8th for quick revision. In the previous video we have learned that how the atoms and electrons are responsible for the flow of current, and we have also seen that the electricity flows in metals, that is solids, as well as the liquids like salt water, tomato juice, onion juice, or even the soap water, but not in the pure water. Tap water, it allows the electricity, whereas distilled water, which is a pure form of water, is a bad conductor of electricity. And rest of the materials which we have used in our previous video, that is salt, tomato juice, onion juice, soap water, all they give, even the tap water, they provide an environment for the charges to flow, and when the charges flow we say that electricity is flown, and the medium is a conductor of electricity, right? We had started understanding the meaning of chemical effect. And what do we mean by chemical effect? Any effect which brings a chemical change is called chemical effect. What do you mean by chemical change then? Right? For example, let us take a hydrogen and oxygen. Simple equation I am writing. And a combination of hydrogen and oxygen will give rise to water. We all know that. It's a simple equation. If I can write this in using proper formulae and symbols, it can be like 2H2, which is hydrogen, 2 parts of hydrogen plus 1 part of oxygen, this is oxygen, gives 2 parts of water, right? This is a chemical reaction. What has happened here? Hydrogen molecule has its own property, oxygen molecule has its own property. 2 of the different molecules combine to give another kind of molecule which is called water, right? A different substance is formed. When a different substance is formed, that is what is a chemical change or chemical effect. Okay. So the reaction which is shown here is a kind of chemical change, right? It can even be, since it can even be a water which can split into hydrogen and oxygen. This is also a chemical change because initially it was water, now it is split into hydrogen and oxygen. Now you have seen 2 equations. Okay, in first equation water is split into a hydrogen and oxygen, right? This is one equation, whereas reverse of this, hydrogen and oxygen combines to give water. Both are chemical changes. And why they are chemical changes? Because new substance is formed, right? If this chemical change is brought into action by using current, right, then that effect is chemical effect of electric current. I hope you have understood what you mean by chemical effect. Now we shall see how this current brings a chemical effect in the substances. For this we need to take a container made up of plastic or a glass, because they are bad conductors, insulators, okay, bad conductors of electricity. And at these 2 points we will fix two metal rods. Either you can take a metal rods or carbon rods, right? And why carbon rods? Carbon is also a good conductor of electricity. Either you can take a metal or carbon, right, or a graphite rod, okay, and then pour water inside. So let us pour a little bit more water and keep some two test tube with us. They are test tubes, and these test tubes are to be arranged upside down over it. Now to fix them properly, we can have this kind of arrangement so that the test tube can stay firm over these carbon rods. Now the next move is that let us connect these two rods to the battery. As far as battery is concerned, we have a red color terminal and a black color terminal. A red color terminal is always a positive terminal and the black one is negative terminal, right? So every battery or every chemical cell which can be represented like this has got positive terminal as well as negative terminal. So if you actually see the battery, a red color symbol is for positive and the black one is for negative. Now we have to connect this. The moment you connect this, then you will find this is a positive terminal, right? And so this becomes a positive and this is negative terminal, this becomes a negative. So we can call it as positive electrode and this is negative electrode, right? So what we have done, we have taken water here, and what is water? Water is given a symbol H2O. It is made up of hydrogen as well as oxygen. Okay, in one molecule of water, 2 parts of hydrogen is there, whereas 1 part of oxygen is there. So you have many H2O molecules all over here. And then we are allowing electricity to pass through. So electrons will move from here, go here, and then enter into water. But if you take a pure water, it will not allow electricity. It's a bad conductor of electricity. And therefore we should not take a pure water in this. Let us take a tap water. Or you add bit of salt or a acid into it. Then it becomes a good conductor of electricity. So what we have to do, take a tap water, water plus salt or water plus bit of acid to make it good conductor of electricity. Now, so then the electrons will move around and the circuit will be completed. Okay, in that case the water will allow the electricity. But remember, what happens at this moment is that water will split into hydrogen and oxygen, right? Hydrogen is a positively charged atom, whereas oxygen will be a negatively charged atom. Let us not go in detail about this. Why this has become a positive charge? Because it has lost some electrons. When the electrons are lost, then the atom becomes positive, and when the electrons are gained, then the atoms becomes negative. So what happens here? The moment H and O are separated into it, H is plus, O is minus, right? So you will find many H plus and many O minus. All these neutral molecules will split into a charged atoms which are called ions, right? So now H plus is an ion, O minus is an ion. Now remember what happens here is there are two electrodes here. We have positively charged electrode here. Here is the positively charged electrode, that is a rod, and here is a negatively charged electrode. That means this has got a positive charge, this has got a negative charge. We know that unlike charge attract, right? Unlike charge attract, therefore this will be attracted by the negative charge. And what is the negative charge? Oxygen. So oxygen, all that oxygen which are split in water will enter into the tube, and you will find bubbles entering inside the water, and finally oxygen is collected here. And since hydrogen is positive, it moves towards the negatively charged rod, and then the bubble formation starts here, and then hydrogen is collected here. Now what have we done? We have split a water molecule into hydrogen and oxygen by using what? By using electric current. Now, is it not a chemical change? Because new substances are formed. We have started with water, and we have taken hydrogen and oxygen in the test tubes. So, new substances are formed, and this is what is a chemical change. And this chemical change is achieved by using current. Right? And this is one example of chemical effects of electricity. What will happen if we take a container not with water? We'll take some other liquid such as copper sulphate. I am writing a formula of that, copper sulphate, right? We'll take a copper sulphate. This is a formula, like how we have water is denoted by the formula H2O. The copper sulphate is denoted by this. Cu is for copper, sulphate is SO4, right? Now, copper sulphate is in a powder form. You have to add bit of water into it, right? Water is H2O. So it becomes a copper sulphate solution. Now suppose if we pass current into this copper sulphate solution, take a battery and connect it into a wire and take two rods, right? And then this is copper sulphate. What is going to happen? We have seen in a previous case of water, right? H2O could split into H and O, right? And then we have collected this separately into the test tubes. What is going to happen in this case? How can we use this demonstration as for our use? In case, suppose if we take a container and instead of water, if we use some other solution, for example, copper sulphate solution, copper sulphate. Together I should have written, there is no space that side. So copper sulphate, sometimes they use different spelling here. The symbol of copper sulphate is formula of copper sulphate is CuSO4. Look at this properly. So it's a combination of copper as well as sulphate. Sulphate is SO4 and copper is Cu. So let us take a copper sulphate solution. And how can you get a copper sulphate solution? Copper sulphate is available in the form of powder. Powder is there. This is a copper sulphate. So what you have to do is add some water into it and it becomes a copper sulphate solution. right? The moment you add, let's say it's a copper sulfate solution, CuSO4. The moment you add a bit of water here, H2O, or add copper sulfate into water, both it becomes a copper sulfate solution. Then you will find copper is split from sulfate. So you will find more of copper plus and sulfate minus ions generated there. So remember this, right? Initially it was together copper sulfate. The moment water is allowed inside, then copper is separated and SO4 is also separated out of this copper sulfate, and they give and take electrons, and copper becomes positively charged and sulfate becomes negatively charged, right? So this is what the status of this copper sulfate solution when water is added into it. Now at this moment, if you take a battery and then put these terminals into a copper sulfate solution, what is going to happen then? You know that this is copper sulfate and bit of water is added into it, which makes copper sulfate to break into copper and sulfate ions. So you will find more of copper sulfate and copper plus and sulfate minus ions, positive and negative ions. Now look at this battery part of it. Since it's red color, it's a positive terminal. This is a negative terminal. So positive terminal has gone to this rod, this metal rod. So this becomes a positive electrode. So this you can write as a positive electrode. And this, since it is connected to negative terminal, this becomes negative electrode. That means negative charges are there on this, and on this positive charges are there, both ends, down and on the top, right? Now solution also contains a positive charge, right? Positive charge and negative charge. We have already studied that unlike charges attract. And what are unlike charges here? We have in the solution, we have ions, right? And what are those ions? They are positive, that is copper one, copper ion, and sulfate ion is a negative ion. And also we have charges on the rod, top and bottom. This is a positive charge, this is the negative charge. So unlike charges attract. This we know already, and therefore copper plus plus, all those which are there in this solution. I have shown only one copper plus plus here just for our reference. So all copper plus plus will start moving towards a negative, right? And all SO4 minus minus will start moving towards positive, because unlike charge attract. So after some time you will find more of copper plus plus are all attracted towards a negative charge rod, that is negative electrode, and all that SO4 minus minus will be near or attracted on the positively charged electrode. Now what has happened here? We have made a copper ions to move towards a negative electrode, right? We have made copper ions to move towards negative electrode. Please remember this point, right? Suppose if you take a copper as a positive electrode, right? Let us take copper as positive electrode. So we shall replace this by copper, right? And then some other metal, let's say, we'll take brass, right? So we have taken a brass here and we have taken a copper here. You can take other metal also in this place, right? Now what happens? As usual, if you allow the current to pass through this copper sulphate solution, there are many Cu++ and SO4- here, and we already know this rod is positively charged and this brass rod will be negatively charged. Why? Because it is connected to negative terminal of the battery, whereas copper is connected to the positive terminal of the battery. So according to properties of charges, unlike charges attract. So the copper which is there in the copper sulphate solution will start moving towards brass. Okay, and you will find all these copper plus will sit on this brass. There will be a kind of copper painting over it, right? And because of that, the copper which is there here in the solution will be getting over, right? And that is replaced by this copper rod, and this copper rod will start becoming thinner and thinner because it gives to this liquid copper plus. In the way we can say it start dissolving into the liquid. And why this has started dissolving into the liquid? Because all that copper plus which was already there has gone and deposited on this plate. So what we have achieved here is we have made a copper ions to go and sit here on this brass plate, and after some time you will find a fine coating of a copper over this. Okay, so this becomes a copper coated, right? So what did we do? We have deposited a copper, one metal, that is copper, over another metal or an alloy by using electricity, right? So we have once again we have deposited a metal, one metal over another metal by using electricity. So deposition of a metal over another metal by using electricity is known as electroplating. This is very important concept. And what kind of electroplating we have done? We have deposited copper over a brass, right? So this is electroplating. In specific, it is called copper plating because we have used a copper. In place of this copper, if you use some other metal, that metal will be deposited on this metal. Point to be noted that the metal on which you want deposition of other metal is supposed to be connected to the negative terminal of the battery. Remember, because this metal is moving towards the metal rod which is connected to the negative terminal. In the next video tutorial, we shall discuss on the topic the uses of electroplating. Thank you.